Hello everyone, so today we're going to go through part 5 of this chapter. So let's first define a surd. So when we have n is an integer, where n is not a square, anything that we square root is called a surd. So any multiple of square root of n is called a surd. By a multiple, we say by itself, it could be called a surd, and also when, for example, it's 2 times square root of 5 is also um, it's a surd. However, what's not called a surd is when the number inside here is a square. For example, square root of 9 is equal to 3 squared equal to 3. So because this number 9 is the square of 3, so it's not a surd. So we're gonna use these rules to manipulate surds in the following examples. So let's simplify square root of 12 in example 12. So 4 times 3. So we're trying to write 12 in a way that we have a factor that is a square. So we can simplify, okay? So a way to write it is 4 times 3. And then using the first rule here, we can do this. And then simply square root of 4, because 4 is a square of 2. So it becomes 2 times square root of 3, which is square root of 3. Oh no, 2 square root of 3. I'm going to simply write it this way. No need for the multiplication sign. So let's move on to the next one. So in what way can we write 20 as a product of a square that we can simplify with? So I can think of 4 times 5 over 2. So writing it this way, 4 times square root of 5 over 2 is equal to 2 over 2 times square root of 5, which is simply square root of 5, because this 2 simplifies with the other 2, right? Okay, so moving to the next one. So we have 5 square root of 6. So how can we write square root of 6 in a way that it's a factor of a square number? Then like we can't. 6 is simply 3 times 2, so we'll leave it as it is. For the case of 24, we can write it as 4 times 6. For the case of 94, it is a multiple of 49 times 6. Okay, so we can simplify here. So 5 square root of 6 minus square root of 4 times square root of 6 plus 49. So I'm just using this rule over here, right there. And this square root covers these two. Okay. So simplifying 5 square root of 6 minus 2 times 2. So the square root of 4 is 2. So it becomes minus 4 square root of 6. Can you see it there? And the last one plus 7 square root of 6. Because all of them, they share square root of 6, what you do is you add, they have a term in common, so you add all the numbers together. So 5 minus 4 plus 7, that's 12 minus 4, which is simply 8 to the power of 6. Not to the power of 6, 8 square root of 6. Okay, so moving on to example 13. So in this question, we've required to expand and simplify if possible. So let's first expand and see if there is any simplification to be done. As you can, if you're having trouble with expansion, I've got a video about that. You can check it out at the end of this one. So expansion, I'm gonna focus on this one and I'm gonna do like this, right? You can see. So 5 times square root of 2 minus square root of 2 times square root of 3. Okay, so we've seen that we go from here to there. Now we're gonna do the opposite. We're gonna go from here to there, where a and b is 2 and 3, so they multiply together and they become minus square root of 6. 2 times 3, okay? Then for the next one, we have 2 minus square root of 3 times 5 plus square root of 3. So I'll focus on this one, I'll do it like this, and then I'll go onto this one, okay? So equal to 2 times 5 plus 2 times square root of 3. And then I'll move on to this one. As a whole, I'm going to use minus square root of 3 times 5 minus square root of 3 times square root of 3. And now it's our turn to simplify. So 2 times 5 is 10. And plus 2 square root of 3 minus 5 square root of 3. And because minus 3 times, it's because it's repeated twice. So we know that, for example, we have a squared, or alternatively a times a is simply a, okay? So it becomes minus 3. Okay, so here 10 minus 3 is 7, and because they share the same term, square root of 3, it becomes minus 3 to the times square root of 3. So now we're done with example 13. Let's explore one example from the exercise set. Simplify the expression over here, square root of 75 minus square root of 12, giving you answer in the form a to the square root of 3, where a is an integer. So let's think of a way to write 75 as a product that consists of a square. So see if we can simplify it. So 75 is 25 repeated 3 times, so 25 times 3, okay? And for 12 is simply 4 times 3. Okay, so 25 is indeed the square of 5, and 2 is a square of, and 4 is the square of 2. So I can do this, okay? 5 squared times this minus 2 squared. I can divide the root onto 2, and it becomes this one, because this is square, so it stays at 5 square root of 3 minus 2 times square root of 3. And simplifying, because they share the same term, I'm going to add minus 2 to 5, and it becomes 3 square root of 3. So now I've written my answer in the terms of a to the times square root of 3, where a in this case is 3. And this marks the end of this session. I shall see you in the next one, and bye.